Hello and welcome to Unit 3. This is Mr. McGough and I'll be going over the Day 1 lesson. First, a bit of review. Simplifying. So here we have a fraction which in the denominator has a complex number. To be able to simplify this, we're not allowed to have a complex number in the denominator, so we have to use the complex conjugate to get rid of the I term in the denominator. Complex conjugate, as a reminder, keeps the same real term and changes the sign on the imaginary portion of the term. So here we're going to multiply both top and bottom by 3 minus 3i. So essentially we're multiplying by 1, which does not change the value, it only changes the representation. We're going to do our distribution property. On the bottom, I'm skipping the middle terms because they will cancel each other out. So 3 times 3 is 9. Positive 3i times negative 3i is negative 9i squared. In the numerator, first I will distribute. So I have 12i minus 8i squared. I squared is the square root of negative 1 times itself, which becomes negative 1. So this actually becomes 12i plus 8. So now I'm going to do my distribution. 12i times 3 is 36i. 12i times negative 3i is negative 36i squared, which I squared is negative 1, so that becomes plus 36. And then I have my second portion. 8 times 3 is 24, and then 8 times negative 3i is minus 24i. Again, in the bottom of our fraction, in our denominator, we have I squared, which is negative 1. Negative 1 times 9 is positive, and negative 9 is positive 9. So in the bottom of our fraction, in the denominator, we have 18. In our numerator, we have 36i minus 24i, which is 12i. And then for our number portions of our numerator, we have positive 36 plus 24, which becomes plus 60. So this is right, but it's not completely simplified. So we need to find a common factor for both the numerator and the denominator. We can see that 12, 60, and 18 are all divisible by 6. So we can rewrite this as 2i plus 10 over 3. Or we can write this as 10 over 3 plus 2i over 3, which is letter D in our solutions. Solving 4x squared equals negative 20. The first thing we need to do is set the right side of our equation equal to 0. So to do that, we're going to add 20 to each side. So 4x squared plus 20 equals 0. Then we'll divide everything by 4. Also a common factor. So we would get x squared plus 5 equals 0. Well, I suppose I could have left that 5 over there. Now I have to get it over to the other side anyway. So I have x squared equals negative 5. And then I'll take the square root of both sides. The square root of x squared is x. The square root of negative 5 is I radical 5. Negative 5 has the factors negative 1 and positive 5. And 5 itself only has factors of 1 and 5, so I cannot get out any pairs from my radical. Unit 3 vocabulary. As you just saw when I did those examples, I had to pull out factors. I pulled out a factor of 6 in my first problem when I simplified, and then I divided everything through by a factor of 4 in my second example. The greatest common factor is the largest factor of 2 numbers. Really 2 or more numbers that we're factoring. A prime number is a number that can only be factored or only has factors of 1 and itself. So finding a greatest common factor. First, we will find all of the prime factors, all of the numbers that will go into our first number here, 6, that are only divisible by themselves in 1. So 6 is divisible by 2, which is a prime number, and 3, which is a prime number. 15 is divisible by 3, a prime number, and 5, a prime number. So the greatest common factor they share in common is 3. Between 16, 24, and 36. So again, 16, we'll start off with 2, which is prime, and that leaves me with 8 when I divide 16 by 2. 8 has factors of 2 and 4. 4 has factors of 2 and 2. So these are the prime factors for 16. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. 36 has factors of 2 and 18. 18 has factors of 2 and 9. 9 has factors of 3 and 3. So you'll notice that every time I had an even number, 16, 8, 4, 24, 12, 6, I always took out the factor of 2. Any even number is divisible by 2, and it'll always be the smallest or the largest reasonable factor to take out first. It's the easiest one. And then once you end up where you're no longer even, then you can look at 3. If 3 doesn't work, try 5. If 5 doesn't work, try 7. Try all of the prime factors. Now, the greatest common factor between these, I have a 2, and a 2. I have another 2, a 2, and a 2. On the first and the second numbers, I have a 2, but I don't have a 2 on this third number out of 36, another factor. I have a 3 and a 3 in my second and third, but I don't have a 3 as a factor for 16. So I've gone as far as I can. So my greatest common factor will be 2 times 2, or 4. For number 3, my factors. For the number first, just 3 and 1. For x squared, my factors are x and x. For the number 12, my factors are 3 and 4 has factors of 2 and 2. For x, the only factor is x. Now I'll go back and collect like factors, a 3 and a 3, and an x and an x. So my greatest common factor will be 3x. Greatest common factor for number 4. 6 is 2 times 3. 14 is 2 times 7. 14 does not have an x along with it, so there's no factor there to take out. So the only thing I can take out is a 2. When I take out a 2, I have left over 3x minus 7. On problem number 5. 4 has a negative 2 and a positive 2. It has an x, and a y. The second portion of this, 6 has a negative 2 and a 3, and an x, and a y, and a y. I can take out a negative 2, I can take out an x, and I can take out a y. Negative 2, x, y. And then what's that being multiplied by? Well, for the first part, I have remaining a 2 and an x. In the second part, I have remaining a 3 and a y. You'll note that it's now plus because I factored out the negative. For number 6, 8 is even. It's divisible by 2. 9 is not. Therefore, if I factor this out, I'd have 2 times 4. 4 is 2 times 2. I have x's in the first expression, z's in the second part of the expression, second term of the expression. So there is nothing that I can factor out of problem number 6. So I just leave it as is. And for number 7, I see I have a w to the third, a w to the fourth, and a w to the fifth. I also can look and see that 5 is only divisible by 5 and 1. That is a prime number. 18 is not divisible by 5. Therefore, I cannot take out any numerical factors. What I can take out, we know that w cubed in the first expression is the lowest power of w. If I take out a w cubed, in the second term, I would only have a w left over. In my third term, I would have a w squared left over. So we'll factor out w cubed. We'll have w cubed times 18 minus 15w plus 5w squared. Factor by grouping. Factor by grouping, the process asks you to find a common factor that we can take out of our expression. Here I have a common factor of b plus 4. And what's that being multiplied by? Well, in the first term, it's being multiplied by a. Plus, in the second term, it's being multiplied by c. So that was already factored for us, but what we're in general doing is we're trying to find something that we can take out from the beginning of our expression that is the exact same as something we can take out or factor out the last part of our expression. Here again on number 9, we have an x minus 3. We can take that up front. And that's going to be multiplied by a plus x squared. Now to apply that. First we look at our expression and see if it's in the order that we want it. You'll see that we took the y term and split it into two parts. That's so that we can try to factor it by grouping. To do this, we'll take the first part, factor it, then we'll take the second part and factor it, and try to get out a common factor. Now, sometimes, if we can recognize the numbers that may be better put together, for example, 3y squared and negative 12, y. And then negative 8y and plus 32. I did that because I see that 8 goes into 32 and 3 goes into 12. So when I factor the first group, I can take out a 3 and a y. From the first expression, that leaves me with a y. I can take out a 3 and a y in the second term, and that also, when I take out that 3y, it leaves me with minus 4. In the second part of the expression, I can take out 8y, but I'm looking back at my first factorization, and I see that I want y minus 4. So I want a positive y minus 4. Oops. So I'm going to take out negative 8. If I take out negative 8 in my first term in this expression, I have left y. If I take out a negative 8 times what is positive 32? Negative 8 times negative 4. So now I have a group, y minus 4. And then I have a second factor, 3y minus 8. In this expression, I want to get the terms with a c in common together, the terms with an a in common together. So I would rewrite this as ab plus a plus bc plus c. In the first expression, I can factor out an a. This becomes a times b plus 1. In the second expression, I can factor out a c, which becomes c times b plus 1. Now I have the factor b plus 1 multiplied by the factor a plus c. So sometimes you can factor the groups just by taking the first two expressions, putting them together, but often you'll also want to rearrange just to make it a little easier for yourself. So next in our vocabulary, we talk about the zero product property. If a and b are expressions, and a times b equals 0, well, we know that anything times 0 is 0. A times b equals 0, so either a is 0 or b is 0, or really both could be. When we talk about zeros for an equation, those are the solutions, the answers, the roots. Has a bunch of different names because they're quite important to us. So let's take a look at problem number 12. We want to find the values for x such that x plus 3 times the quantity x minus 5 equals 0. So for this, we can set each of the terms equal to 0 and solve. Subtract 3 from each side. For the first one, x equals negative 3. The second one, add 5 to each side, x equals positive 5. So if we put positive 5 back into our expression, 5 plus 3 is 8, times 5 minus 5, which is 0, 8 times 0 equals 0, etc. On number 13, there are two expressions. One of them is y. If y equals 0, 0 times 4y minus 9 also equals 0. The second part, 4y minus 9 equals 0. We add 9 each side and divide by 4. So y could equal 9/4. On the last one, number 14, well, what would be the first thing we have to do? Oh yeah, we're going to factor it. So we take the second and the first expression, try to find something in common. The first expression is a times a. The second expression is negative 12 times a. So they have an a in common. So a times a minus 12 equals 0. So either a equals 0 or a equals positive 12. So you'll notice that on those three, we had 0 already on the right side, or just really one side of the equation. If you don't already have 0 on one side of the equation, you have to adjust your equation to get 0 on one side. So here we'd have 5z squared minus 30z equals 0. We can factor out a 5z times z minus 6. Either 5 times z equals 0, so z equals 0, or z minus 6 equals 0, so z equals 6. On number 16, we can factor by grouping. Here we have y times y plus 5 plus 5 times y plus 5. That equals 0. So we can take out our y plus 5 term, y plus 5. And what's it being multiplied by? Well, first it's being multiplied by y, and then it's being multiplied by plus 5. So here we have both of the terms the same. So either y equals negative 5 or y equals negative 5 again. So there's only one answer for this one. It's a double root. The same number comes up twice. So on number 17, this time I have 8x squared minus 6x minus 12x plus 9. I'm going to rearrange it a little bit, as you see here, so that I have 8x minus 12x. So I can factor out 4x. If I factor out a 4x, I'm left with 2x minus 3. On my second expression, I want to end up with a positive 2x minus 3 as my second factor, so I'll factor out negative 3. That leaves us with 2x minus 3 as our second factor. So 2x minus 3 times 4x minus 3 equals 0. I'm going to set each of these equal to 0. 2x minus 3 equals 0, or 4x minus 3 equals 0, and solve. Either x equals 3 halves or x equals 3/4.